Hello, I just want to do a really quick presentation on the mathematical order of operations. Super brief, just want to talk about the history, usage, some of the ambiguities and misconceptions, which I see a lot. The roots of the order of operations really goes back to the 16th, 17th century in European mathematics. It goes way back. I know I see a lot of people comment and say, "Oh, it must be an American thing," and etc. But it goes way back into the 16th century. Standardization arose to ensure consistent interpretation of expressions. Early mathematical texts established conventions for clarity, and it's really been adopted globally to reduce ambiguity in communications. You can imagine how confusing it would be if everybody had their own set of rules. It was first really mentioned, at least in Western civilization, in some early algebra books back in the 1600s. Textbooks later in the 1800s really formalized teaching. As more textbooks were created, you had more of a formalized teaching of order of operator precedence. There are international variations influenced by educational systems, but those variations really still result in the same answers. Um, and a little bit about calculators. I see this pop up quite a bit with calculators, just to jump over to that topic. But there's really two main input modes on different calculators. You have immediate execution mode and expression mode. Immediate execution mode evaluates step by step as things are entered. And if you're not aware of that and you're working with a problem that has mixed operations, where you're mixing, say, multiplication with addition or subtraction, division, multiplication, addition, any combination of those, you can get the wrong answer if you don't understand how to use that type of calculator. Expression mode parses out the entire expression before it calculates. So it keeps track of everything that you enter, and then when you press the equals key on your calculator, it knows to evaluate the entire expression based on the order of operations. Mode differences can cause a lot of confusion, like as I said, when you're mixing operations. So be careful with what type of calculator you're working with. Um, Also, expressions like 2 times the quantity 3 plus 4 sometimes can be misinterpreted. This is a case where the 2 and the left parenthesis here, let's see if I can get the pointer. Um, you have the 2 and you have this left parenthesis. This is assumed to be multiplication. What's assumed here, it's called implicit multiplication. And implicit multiplication, you don't have the multiplication symbol, but this actually represents 2 times 7, because 3 plus 4 is inside of parentheses. It's added together, and then you take 2 times 7. But it can be misinterpreted because certain systems give implicit multiplication higher precedence. So whenever you see that type of multiplication, there have been some standards that give that implicit multiplication higher precedence than, say, explicit multiplication. Now, when I say explicit multiplication, I mean multiplication that actually shows a multiplication operator, the multiplication symbol. So again, some systems do that, but if you're strictly following the way that PEMDAS and BODMAS are interpreted, um, it's treated equally. So a lot of others treat it equally, implicit multiplication to explicit multiplication. So it can lead to some differing results across calculators and software. There are some Casio calculators that give implicit multiplication higher precedence than division or explicit multiplication. Just something to be aware of. It's one of those things you'll see a lot of the viral problems online that deal with that. And there's all these different acronyms that people have memorized depending on where you're from. There's PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction. That's pretty common in the US. You have BODMAS, brackets, orders, division, multiplication, addition, subtraction. That's pretty common in the UK and India. There's BIDMAS, um, brackets, indices, division, multiplication, addition, subtraction. And it's listed here as a UK variation. I'm not exactly sure where all this has been used. I believe maybe Australia where it's BIDMAS or BEDMAS. Somebody may chime in the comments and let me know because I honestly get confused where all these are used. BEDMAS maybe more common in Canada, and maybe other countries too. You can let me know which one of these acronyms you might be familiar with. Brackets, exponents, division, multiplication, addition, subtraction. Now, the thing to keep in mind is, despite the different letters used and despite the differences, the results are consistent if the rules are applied correctly. So even though PEMDAS has the M before the D, and BODMAS and the rest of these have D before M, it doesn't matter because division and multiplication have equal precedence. Division is simply multiplying by a reciprocal. And the same thing, addition and subtraction have equal precedence as well. Just because you have the letter A before the letter S does not mean that you try to force addition before subtraction. They're the same precedence. It doesn't matter. Um, so a lot of times people mistakenly see all these acronyms as some kind of a strict six-step checklist, which is false. Again, multiplication and division share priority. They're just evaluated left to right. Addition and subtraction also share priority. So misreading these acronyms leads to a lot of errors. The other common thing I'll see people do is some believe the order of operations can be skipped if there's no parentheses present. That's not true. I see people say that all the time, and they're very, very confused on how the order of operations works. The convention always applies regardless of parentheses. If you don't have parentheses, you go to the next step. Parentheses are just grouping symbols. They just simply override the default precedent. The order of operations ensures consistency and clarity. The calculator modes can affect outcomes. Implicit multiplication can introduce ambiguity depending on whether you give that priority or not. Acronyms are guides, they're not rigid step lists, checklists, okay? And misconceptions can lead to errors in everyday math. So hopefully that's been helpful. This is just a real quick presentation on the order of operations. I've got a lot more information. I have an entire playlist of the order of operations, a lot more detailed, a lot of example problems as well, some of the viral ones that you'll see online. So hopefully this has been helpful to you. If so, please consider liking, sharing, subscribing, and I look forward to seeing you in the next video.